American Axle and Manufacturing, AAM, builds OEM axles for Chevrolet and GMC trucks, Dodge trucks, and the Ram. The bump to 35-inch diameter tires on our Dodge Ram 3500 required a gear set change from 373-1 to 456-1. The right tools are an important part of any axle build. The AAM units require some specialty tools, and in this step-by-step coverage of the ring and pinion gear set change, tools play an important part. Some tools are inexpensive, others can be improvised. A few will require your willingness to invest in tooling. Use wheel chocks to prevent vehicles from rolling. Once jacked up on a slope, the vehicle will roll whether in park, gear, or even with the e-brake set. Always use a quality set of jack stands and a rated floor jack. The Pittsburgh floor jack rating is 4 tons. Our Dodge Ram 3500 is now over 8,900 pounds curb weight. These walker stands rate 5 tons per pair for an evenly distributed load. This provides an adequate margin of safety. Note placement at the base of the axle tubes, between the spring U-bolts and away from the brake tubing. Tires are just off the ground and can be removed readily. The Ram 3500 has a full floating rear axle, as do many of the AAM applications. This makes differential work much easier. Axle shafts are quickly removable. Rotors and calipers can stay in place. Begin by draining the axle oil into a clean pan. Inspect for metal and debris. You'll wipe out the differential cavity with clean lint-free rags. This properly maintained oil on the Ram 3500 is clean and free of contaminants. Original equipment 3.73 gears worked for 100,000 miles just fine, right up to the switch to 35-inch tires, a 3-inch diameter increase. 410-1 would be a direct correction for the tire size increase. 4.56-1 meets plans for trailer pulling, plus the added weight of accessories and auxiliary fuel. We selected 4.56-1 based on research from Cummins and our trailering needs. With 35-inch diameter tires, 410-1 is a direct equivalent to the OEM 373 gearing with the original 31.9-inch tires. Full floating rear axle shafts are easy to remove. Begin by removing the 8 flange bolts. Unless there is a threaded relief hole, use a wedge-shaped, broad chisel to separate the axle shaft flange from the hub. As a caution, do not damage the metal. You're merely trying to spread these parts at the gasket, not chisel or nick the metal. Axle shaft removed, the hub, spindle, and wheel bearings are now visible. Note that there is no mark where the chisel separated the axle shaft from the hub. The axle shaft and hub have been indexed with yellow marker for alignment at reassembly time. The virtues of full floating axles are clear. The vehicle will safely roll with the shafts removed. Note that oil will leak out under those circumstances. This is a distinct safety advantage over a semi-floating axle. This time-honored, heavy-duty, full-floating truck design provides ease of service. The differential assembly can now be removed. The spring locks keep the differential bearing preload nuts from rotating. Remove these bolts and springs to make adjustments or remove the differential. Loosen the opposite retaining bolt and spring lock. Note the relationship of these parts for reassembly. Bearing caps are a machined match for the axle housing saddles. To maintain precise fit, you must install caps in their correct positions, with the caps facing the right way. Here, one light pin mark at the left cap and housing indicate the cap alignment for the left bearing cap. The right bearing cap gets 2 pin marks. Note that the marks should indicate which side and how the cap faces, top to bottom. Bearing caps marked. You can now loosen the bearing cap bolts. Do not remove these bolts until you can safely support the heavy differential carrier and ring gear. Remove the bearing cap bolts. Rock the cap slightly to loosen if necessary. Do not distort the cap or mar the cap to housing surface. This is a precise machine fit. Protect the bottoms of the caps and the housing. A precaution here. Leave the bearing cap bolts in place if the adjusters do not securely hold the differential in place. Badly worn bearings or misadjusted spanner nuts can allow the differential to roll out of the housing once these caps are removed. The 11.5-inch differential carrier and ring gear are heavy and can cause severe physical injury if not supported during removal. In this case, the bearing adjusters were tight with preload. Do not allow the differential to roll out of the housing. If you're not certain that the adjusters will hold the bearings and differential in place, leave the bearing caps in place with the bolts finger tight, loose enough to permit backing off the adjusters. To avoid parts damage, do not let the toothed toner ring drop onto the housing. Here, the right side spanner nut is still tight. The marring of the holes in the spanner nut is actually caused by the retainer springs. This axle has never been apart. While some use a punch with a blunt, rounded nose end to tap the adjuster rings loose, there is a factory service tool for the task. This is Miller SPX number 8883A, the official tool for the adjuster nuts on AAM 9¼ inch and 10½ and 11½ inch Chrysler, Dodge, and Ram axles. There's a similar tool for GM axles. If you want to do this job correctly, consider purchasing the Miller tool or the equivalent tool for GM axles. The Miller SPX 8883A tool is available at the SPX website. There is a caution that goes with this tool. Do not use for removal, meaning that the Miller SPX tool is high quality and well designed for this difficult application. However, the tension on these adjuster nuts can be extreme and exceed the ability of this tool. AAM's 11½ inch axle design creates decreasing notch exposure as the adjuster rings thread into the axle housing. This requires a thinner tool, one not capable of handling excessive force. If the AAM axle adjuster notches were fully exposed over the range of adjustment, a thicker, stronger tool design would be possible. There are occasions, however, when an overly tight nut adjustment, binding spanner nuts, or axle exposure to heat can increase the torque resistance. Given the constraints and the tool design, this alloy steel SPX tool will take considerable load before its small notch tab fails. Before this happens, some use a blunt, rounded end punch and hammer to break the initial torque on an overly tight adjuster nut. If you do use a punch, do not damage the adjuster rings. Vacuum away any metal debris from the axle cavity and all gear parts. The tool shown here was fabricated at our shop. It emulates the function of the Miller SPX tool. At the end of this feature, there is a bonus section on how we constructed this tool. Bearing adjusters are right-hand thread and loosen into the axle housing. Fine housing threads must be handled carefully. Back off the adjusters carefully and be ready to catch a heavy 11½ inch ring gear and differential assembly. A block of wood beneath the tone ring will prevent teeth from dragging or banging against the axle housing as you roll the differential assembly from the bearing saddles. Note that a support platform like a transmission jack is helpful. Support the differential assembly to prevent damaging the tone ring teeth. Avoid pinching or crushing your fingers. If an assistant is nearby, ask for help. Does this look big enough? This is the 11½ inch that can tow a 9-horse trailer and handle dual wheels and a diesel engine. To avoid severe injury, don't get pinned beneath this differential and ring gear assembly. Use a transmission jack and strap the safety chain too. The 373 pinion gear remains in place at this point. Mark and remove the threaded bearing adjusters. You'll want to clean and oil them to assure smooth adjustment during differential installation. Bearing cups fit precisely into the housing saddles. Adjusters thread into the axle housing at each side. These parts must be clean for proper fit and accurate adjustments. Mark the adjusters with a pin punch for proper location on reassembly. You can use this taper tool to loosen the adjuster ring from the axle housing. The rings should rotate freely if threads are not damaged. Loosen and remove all the ring gear bolts. These bolts may be extremely tight due to factory thread locker, which is equivalent to Loctite 271 high-strength red. A high-torque air wrench and moderate heat, 500 degrees Fahrenheit maximum, may be required to loosen these bolts. Be aware that ring gear bolts can be left or right-hand thread. Inspect the threads of the new bolts before loosening the old ones. Inspect the ring gear threads closely to be certain you know whether they are left or right-hand thread. Unless there's an issue, the ring gear can be removed by tapping 4 loosened bolts at opposite positions on the carrier. First loosen all of the bolts, then lightly tap in sequence the 4 bolts to prevent the gear from binding on the carrier. Do not strike or damage the carrier casting. Tap and cross. Anytime you remove the ring gear, the bolts should be replaced. Always use proper ring gear bolts. If you plan to reuse the ring gear, be cautious. Do not damage the threads as you remove the ring gear. Tap with a brass punch at the beveled edge of the gear, gradually and in cross. The ring gear dropped off uniformly and quickly. Note the factory sealant powdered on the gear threads. This created strong resistance when removing the bolts. The tone ring can stay in place. Leave the tone ring to carrier screws tight. Observe the original tooth contact pattern. This OEM 373 ring gear worked just fine and shows a distinct and correct tooth contact. If correct, try to emulate a similar pattern on your installation. Take a close look at the tooth contact pattern. The rear drive shaft can now be loosened. Mark the pinion flange to U-joint flange for reassembly. Drive lines are often balanced as a full assembly. In any case, if there were no signs of imbalance, indexing will prevent any future issue. Note that the flange design and pinion seal ID can vary between applications. Pictured here is a Dodge Ram approach and parts orientation. Make sure the new replacement seal and parts are for your axle type and vehicle model application. 4 bolts removed, the drive shaft is carefully set to the side or wire tied out of the way. On a one-piece shaft like the 140.5-inch wheelbase Ram 3500, keep the slip yoke in place at the transmission or transfer case. This will prevent oil from leaking out and save time during reassembly. Protect the transfer case or transmission output seal. Use of a yoke holding tool and air impact wrench is the safest way to remove the pinion nut. Used properly, an air wrench is far less risky than a long breaker bar, socket, and muscling the nut by hand. Here, the other end of this long-handled yoke holder rests firmly against the floor. Know which direction the yoke tool rotates before applying force to the pinion nut. The yoke holds the pinion flange securely, and the nut comes loose readily with high force impact. You should use an impact-rated socket for this task. The 12-point socket size is 36 mm on AAM 11.5-inch Chrysler applications. A quality impact socket can get expensive in this size 12-point. Safety is at stake. Sometimes, especially on lighter axle applications, the pinion shaft can be danced carefully through the flange and front bearing with an air impact driver. A caution here. Use a tapered, blunt, or round end tool, not a chisel point. Impact force will cause less trauma than tapping on the pinion shaft's end after the splines have been coated with factory Teflon paste. The flange was so stuck in this case with Teflon paste that a puller was necessary to remove the flange. Splines are not tapered. The resistance here is from the paste, which took considerable force to overcome. This paste is more like cement after 110,000 miles of driving. Cleaning takes solvent and time with a brush. Paste is evident on the splines of the pinion shaft. This is all with good intentions to prevent gear oil from wicking out the shaft splines. Years past, Permatex 300D gasket sealer worked just fine for this task. Loctite Superflex RTV is our reassembly choice. OEM calls for Teflon paste, like Loctite 592 PST, your choice. Inspect for nicks or a seal lip groove issue. Polish the seal riding surface. At this point, the pinion gear remains in place because the front or flange end bearing is a press fit onto the pinion shaft. The pinion shaft gets tapped through the front bearing, which will be replaced with a new bearing cone and cup. Not intended for reuse, this shaft was tapped through the front bearing with considerable persuasion. During assembly, the front bearing is a press fit onto the flange end of the pinion shaft. An attempt with a curved pry tool failed to remove this seal. This approach works better. Make sure your chisel point is sharp, tapered long, and narrow. Catch the seal edge without gouging the axle housing casting. Work the seal inward and out, avoiding force against the iron casting. The seal came out in less time than rummaging for the special seal puller in the toolbox. Seal out, the loose bearing cone comes right out. You should now replace the bearing cups, shown here, and the cones. Note that there are no marks on the housing from the seal removal with the chisel. Despite available specialty pullers, a quick and effective way to remove bearing cups is via a hefty tapered punch with a squared end. There are reliefs at 180-degree points in the housing. The flat punch end can safely catch the shoulder of the cup. A caution here. Tap back and forth between the two relief points, carefully and uniformly, to prevent binding the bearing cup or damaging the housing bore, where eye protection, the punch and bearing steel is very hard. The inner gearhead bearing cup is now removed. The bore is unmarked, not blemished in any way. Use care and the two relief points for the blunt end punch. Again, the tapered punch works well on the bearing cup at the pinion flange or nose end of the housing. This is a smaller cup. Stay on the bearing cup edge and avoid damaging the axle casting. Tap side to side, 180 degrees apart. If you're not confident about the use of the punch, use a bearing cup driving tool. A quality bearing spreader will lift the carrier bearings from their seats without damaging the crown or flanges of the differential carrier. Do not squeeze the spreader to the point of interfering with the differential flange. Using an adapter within the border of the carrier flange, this 3-jaw puller gradually works the bearing loose. A puller of this kind has no means for holding the jaws inward, however. The better tool of choice here would be a Posi lock puller. Though tedious and requiring considerable caution, this puller does remove the bearing. See how much more effectively the Posi lock puller does this task. Note that the jaws are pulling against the inner bearing race and not against the bearing cage. This is the Posi lock gear and bearing remover. The Model 208 shown will also accept optional transmission front bearing jaws for pulling via the bearing snap ring groove. Force for this tool is 12 tons, with a side clamp preventing jaws from spreading under this force. With an adapter on the carrier flange end, the Posi lock grips the base of the bearing. If jaws are narrow enough, they will fit the 2 notches in the carrier case. Here, the bearing spreader has lifted the bearing cone high enough for the Posi lock's jaws to safely grip the bottom of the bearing's inner race collar. The original pinion shaft bearing is removed to access the pinion depth shim. This is a crucial reference if you are not setting up the pinion depth from scratch, with discs, an arbor, a pinion block, a scooter, and dial indicator. Note that the factory method for setting pinion depth is now the full pinion depth gauge apparatus. This is a definite for a new blank axle housing. On a used or properly functioning axle, it is just as practical to use the method described here, with dummy trial bearings and tooth contact tests. About as quick too, since we always run tooth contact pattern tests, regardless of the pinion setting method. The dummy bearing procedure described in this video makes pinion depth setup much simpler and quicker if you do not have a pinion depth gauge fixture and specialty tools. The angle steel towers you see here with the flat platforms on top support the bearing spreader squarely. Towers offer a place for the large pinion gear to drop. The press applies pressure to the old pinion shaft's end, forcing the bearing off the shaft. In this example, the original pinion depth shim is 54 thousandths of an inch thick and numbered so. This is a baseline for setting depth. Adjustment of the shim thickness will depend upon the tooth contact pattern results. We will start with a 54 thousandths inch shim stack, built with new shims provided in the rebuilt kit. Note that on these AAM axles, there are no plus or minus marks with thousandths of an inch pinion variance indicated. That was once a reliable means for setting pinion depth on an axle, at least a starting point. A ring and pinion gear installation kit includes new shims for the pinion depth. Shown here is the original shim. A crush sleeve eliminates the need for shimming the pinion bearings to set the pinion preload. The crush sleeve is a big time saver. Lube guard is a high lubricity thin assembly oil. Unlike the OEM recommendation of using gear lube for assembly, this oil reduces friction dramatically and is not temperature or pour sensitive at shop and reasonable outdoor temps. Lube guard also helps prevent galling of bearings and machine surfaces during assembly. A light coating does the trick. Your choice. When pressing on new bearings, make sure the bearing rollers and cage are not binding or getting squeezed in any way. Check rotation constantly. Here an adapter rides on the inner bearing collar as the bearing presses onto the flange. Lube guard prevents galling and bind. Press squarely. This inexpensive bottle jack 20-ton press frame gets a lift from a 20-ton air-over hydraulic jack. The jack can work with compressed air or by hand hydraulically. Yes, there are expensive presses tailored for this work. This one works fine for less frequent use. A dial pressure gauge would be a practical accessory. This step-bore driver tool serves as a press tool. The aim is to avoid any pressure on the bearing cage. The tool must also clear the carrier flange. Watch how this works. The tool rides inboard of the bearing cage and outboard of the carrier flange. Pressure is against the inner collar or race of the bearing. This tool also clears the differential carrier flange at the inside diameter of the driver. The inside step of the tool allows the bearing to end up below the lip of the carrier flange. The tool must clear the lip. Make sure that the bearing seats completely. If necessary, improvise this tool with pipe. Protect both the bearing and flange. Warming up the ring gear makes installation easier. Using our parts washing cabinet heated at 145 to 150 degrees Fahrenheit, the gear goes for a 10-minute wash and winds up uniformly saturated with heat. Use protective leather gloves to set the gear in place quickly while uniformly hot. Make sure the bolt holes align as you set the gear on the carrier flange. Use pilot studs if necessary. Pilot studs are simply long bolts of the same diameter and thread pitch as the ring gear bolts. Cut the heads off, and if you want to be creative, file a screwdriver slot at the end of each stud. Two studs placed 180 degrees apart can act as a guide for the ring gear. Once the gear drops in place, unthread the long studs from the ring gear threads. As a caution, do not use a torch to heat the ring gear. The temperature described here is plenty. This is alloy steel and not a candidate for much expansion. Too much heat also risks damaging the gear's case hardening, and you don't want that to happen. Make sure ring gear bolts have thread locker. Often, new bolts included in a rebuild kit have OEM type thread locker already on the threads. Red Loctite 271 is the high strength needed for this application. Do not waste any time with Loctite 271 setting up. Use as prescribed and get ready to torque hardware to specification. Not only does Loctite 271 help prevent bolt loosening, it also helps maintain original torque settings as the load on the ring gear tugs at hardware over time. 11.5-inch AAM axle ring gear bolts take 175 foot-pounds torque by OEM recommendation. Tighten bolts a few threads at a time and cross uniformly and gradually come up squarely to torque settings. Do not cock or bind the gear on the flange. Make sure the gear remains square with the flange. Bring torque to specification in gradual steps. This accurate 0 to 250 foot-pounds torque wrench makes several trips in cross, gradually increasing torque starting at 75 foot-pounds, then 100 foot-pounds, 150 foot-pounds, 175 foot-pounds, then again at 175 foot-pounds. Let the bolt set for 5 minutes after final torque is reached, then do the entire set at 175 foot-pounds again. If you need to brace the assembly, use safe anchor points and do not damage parts. For setting pinion depth, a trial fit can be quickly made with the use of dummy bearings. If the original bearings are in reasonably good condition, carefully route out the inside diameter of the bearing cones, just enough to finger press fit the bearing onto the pinion shaft. Used bearing and shaft measurements will be very close to the new pinion shaft and new bearings. As a footnote, for axles without crush sleeves, make dummy bearing cups and cones for trial fit. Remove a slight amount of material from the outer edge of old pinion bearing cups, just enough to finger press the cups into the axle housing bores for trial shimming and testing. When the preload is correct, you can install new cups in the housing and press bearing cones in place. Use the correct shim stack thicknesses as determined during the trial testing. An inexpensive drum sander arbor and coarse sanding disc can remove the slight amount of bearing steel from the inner bore of the bearings. Bearings are hard, so use gritty abrasive to save time. Sand evenly to keep the bearing bore round. Continually trial fit the bearing to the shaft. You want just enough sizing to permit the bearing to fit on and off the shaft squarely using hand force. These original bearings were both fitted to the shaft by hand. There is no looseness to the fit. They are round and sized enough to slide onto the shaft. Clean the bearings thoroughly and oil with light assembly lube. Now the dummy bearing fits to the new pinion shaft and gear. A stack of shims is at the OEM thickness for the first depth check. The bearing slides snugly onto the shaft and will come off with hand force. This serves as a quick trial fit. This is a professional-grade OEM-type bearing cup driver tool. It fits the bearing cup's taper and has a strong shoulder for squarely driving the cup edge. The cup must be driven straight, not bind or gall, entering its bore squarely. A cup driver tool installs the new inner bearing cup. This cup will be seated squarely and oiled lightly for trial fit. Lube guard works well to reduce friction and provides an accurate depth measurement and bearing preload. The new cup squarely in place and seated, the bearing cups must bottom in clean bores and fit tightly without galling or any interference from debris. For accurate pinion depth and pinion preload settings, these new cups must fit properly. Confirm seating from the other side. A clean, prepped bore prior to installing the front pinion bearing cup, the smaller bearing cup, if driven squarely, will enter the bore without trouble. Note that the new bearing cup seats squarely. Look at the bearing seat edges from the opposite side. Be sure the cup seats all the way and snugly. This assures proper preload settings for the bearing. New bearing cups squarely seated. The pinion depth trial fit can start now. The new pinion shaft will use the dummy bearings and a 54,000th of an inch shim stack in this case. Use your original pinion shim thickness for the first trial test. The new pinion shaft fits through the dummy front bearing. The dummy bearings fit with the first trial stack of shims. Preload adjusters are oiled lightly and threaded into the axle housing at each side. Adjusters must turn freely without drag or notchiness. For trial fit, the pinion seal is left out, and so is the crush sleeve. Grind the pinch section off the old pinion nut, enabling it to thread on and off the pinion shaft easily. This saves time and gives a quick read of pinion depth and the gear tooth contact pattern. For now, tighten the nut to either the factory preload setting or zero play plus light rotating resistance. Consider using a transmission jack for the 11.5-inch AAM differential carrier. This assembly is heavy. Here, a transmission adapter on a floor jack works well. The differential carrier goes into position. The bearing cap bolts can be tightened with a box-ended wrench by hand at this stage. Then back off the cap bolts 1/4 turn or so to enable smooth rotation of the side adjuster nuts. A quick check of tooth contact pattern can be done with a short stretch of painted teeth. This is the yellow marking compound furnished with the axle rebuild kit. Set the backlash close for this check, a barely perceptible rock of the ring gear. Set a light load on the carrier bearings using the spanner tool. This will center the differential for an accurate read of pinion depth with bearing cap bolts snug. Make note that here it is clear that the pinion is not reaching into the ring gear teeth deeply enough. The pinion gear rides high on the drive side of the ring gear teeth. The ring gear coast side also shows high riding contact. Note how the print is somewhat centered, but high toward the crown or top ridges of the teeth. Mesh can go deeper toward the flank or root of the teeth. This requires moving the pinion higher, more toward the differential axle shaft center line. American Axle and Manufacturing uses two gear cut types, the 2-cut and the 5-cut. The sweeping pattern that you see here is a 2-cut, where the tooth height is measured from the root or bottom of the tooth to the crown or top of the tooth. The 5-cut tooth pattern has the height shorter at the toe or inside of the gear and taller at the heel or outside of the gear. The 5-cut gear set appears as a square pattern when the set is rolled with gear marking compound. The 2-cut gear pattern is more like a feather. The 2-cut tooth is the same height at the toe or inside of the gear as it is at the heel or outside of the gear. The 2-cut gear set has a natural bias condition, that is, that the pattern shows up slanted when rolled with gear marking compound. Gear sets built by AAM come with an installation sheet that explains whether the gear set is a 2-cut or 5-cut type, and how to set the gears up. When rolling the differential in and out of the axle housing, avoid risk of damaging the tone ring. Use a block of wood beneath the tone ring. The jack platform is able to catch the weight and allow handling by one person if necessary. Do not damage the tone ring. This tooth contact pattern is looking much better. Even without full pressure or drag on the ring gear, it's clear that the pattern is both centered properly and below the ridge of the teeth faces or crowns. This is actually the second retest. 57 thousandths of an inch was not enough, and the pinion head has been raised to 59 thousandths in this case. This is a coast pattern, and it's starting to look good too. Spread across the tooth, below the face crown, and not too deep into the root or flank. This is with some resistance created at the pinion flange to press and spread the yellow marking compound, helping to simulate actual load on the gear. To remove the differential and install a new bearing on the pinion shaft, the adjusters must be backed off. With the cap bolt slightly loose, the adjusters are moved with a round, narrow tool, like this Torx driver. Note that the Miller SPX 8883A spanner will only loosen these adjusters so far. Adjuster holes disappear into the housing, becoming narrow slits. Make sure the bearing is not bound. Pressure is against the bearing's inner collar only. Any pressure outboard of the collar can damage the bearing cage, rollers, or contact surfaces. Here, a stack of 59,000 shims is fitted onto the pinion shaft. New inner bearing gets pressed into place. 59 thousandths of an inch is correct for this installation. This is not a universal truth, and each axle is different for both the OEM shim thickness and the correct shimming for the new pinion gear. The difference in this case is 5 thousandths of an inch, which also varies between installations. Look for your axle's correct tooth contact pattern. Here the bearing gets pressed into position. There's support from below on the inner bearing collar. The old race is strictly to keep the rollers and cage in position. Force is against the inner bearing collar. Keep shim centered until the bearing inner collar seats completely with some pressure. You want compression of the shim stack. The new crush sleeve is in position here. This crush sleeve must be in place when you insert the pinion shaft through the new front bearing and seal. Here, the rear axle housing accepts the new front or flange end bearing cone. Make certain that you install the crush sleeve on the pinion shaft before running the shaft through this bearing. You can install the new seal first. This will help keep the bearing in place. This ring and pinion gear set kit included a tube of Loctite Superflex Blue RTV sealant. A thin coating on the seal jacket or edge backs up the neoprene seal. Use sealant sparingly. An even, uniform coat will do. Note that Dodge, Ram, and GM applications use different yoke flange types and seal ID sizes. Make sure you have the correct pinion seal for your application before installing the pinion shaft and flange. Superflex is an excellent sealant. With a tool chest drawer full of seal drivers, this approach works just as well. Tap evenly and prudently around the seal flange edge. Do not bend the seal flange edge, and make sure the seal goes into the bore squarely. Here, the seal is installed properly, square and evenly seated on the flat nose of the casting. Grease is inside the seal lip. Spread this grease evenly to lube the pinion sealing joint. Make sure the pinion flange's sealing surface is clean. Polish it with fine crocus cloth or 3M Scotch-Brite pad if necessary. Remove all debris. Careful application of sealant can reduce risk of any oil seepage. The Loctite Superflex works well here, applied to the splines in the inside face of the flange. When the flange is installed, this mating surface will seal against the bearing inner collar. Oil wicking is prevented by using correct sealants. Note that the OEM manuals recommend Teflon paste on these splines. You can do that if desired. This installation opted for Loctite Superflex Blue RTV. Loctite 592 PST thread sealant would match the OEM material. Wipe off excess sealant before installing the flange on a clean, dry pinion shaft. Make sure the new crush sleeve is in place. Keep the pinion shaft on center. Run the pinion shaft's threaded end through the bearing while centering the flange with the pinion seal. Bring these parts toward each other. Do not distort the seal lip or spring. The pinion seal can be installed after seating the front bearing on the pinion shaft if desired. If that seems easier, install the flange without sealant. Installing the flange pulls the bearing into position. Stop short of preloading the bearings at this point. Remove the flange and install the seal. Reinstall the flange with sealant as shown here. The flange can be pulled into place with the washer and the nut that you modified for your shim tests. Keep the shaft on center as you tighten the nut. Use the flange holding fixture and an air impact gun. Draw up slowly and steadily. Do not crush the sleeve yet. Remove the temporary nut after seating the flange against the bearing collar. The bearing is in place, securing the shaft as the nut and washer come off. Coat the washer face with sealant. Fill the cavity around the base of the threads as needed. Some use 271 Loctite high-strength red on the new pinion nut threads. The nut is self-locking, and Loctite 242 blue, applied generously, is a good safety margin and added sealer. Your choice. The new pinion nut, provided in an installation kit, now has a coating of Loctite 242 on the threads. If you use an air wrench at this point, be certain not to over-tighten the crush sleeve. Torque required to crush the sleeve is very high, around 300 foot-pounds. Use any high-torque air impact wrench with caution. Be aware, you must not over-tighten the crush sleeve, or you will have to replace the sleeve with another new one. Over-tightening cannot be followed by simply backing off the nut, although unaware installers have done this. The result is an unloaded front pinion bearing and risk of bearing damage. Worse yet, the pinion nut could come loose, and the shaft and gear set would fail. The force of the crush sleeve is a key element for bearing preload, keeping the pinion nut secure and holding the front pinion bearing in position. A good air wrench for this project is the Chicago Pneumatic Model CP7748 composite air wrench, a great value. In real terms, this impact wrench can controllably crush a new pinion sleeve. This half-inch air wrench lives up to claims, delivering peak torque at a lower CFM than much more expensive products. Some manufacturers claim even higher torque output, but require 29 CFM or an unrealistically high RPM to do so. Watch the RPM and air requirements on Air Tool ratings. Actual specifications for a pinion bearing load are in inch-pounds. This FlexBar Duro wrench has adjusted transmission bands and pinion bearing preloads for decades. Reliable and easy to read as the shaft rotates, a FlexBar torque wrench works well for this kind of task. Bearings should be lubed with a light assembly lube or the oil that comes with the new bearings. This assures free movement without any kind of drag. Here the crush sleeve is coaxed very slowly with the air wrench. The rotating torque is stopped at 22 inch-pounds for the new bearings. After stopping at 22 inch-pounds, we lightly wrap the shaft from both the front, as shown here, and the gearhead end with a sandhead plastic hammer. This seats the bearings. Recheck the rotating torque again. The pinion flange is now sealed and seated, with the crush sleeve compressed and crushed at 22 inch-pounds of rotating torque, which is different than startup torque. 20 to 25 inch-pounds is factory recommended for new pinion bearings in an AAM 11.5-inch axle. Based upon the shim and tooth contact tests, this should be the optimal height depth for the pinion gear head. Marks on heads of AAM gears are not pinion variance readings like a Dana and other axle types. The best setting overall is a correct tooth contact pattern, correct backlash, and 0.02 of an inch or less ring gear runout. Runout is the waver of the gear, not to be confused with the required backlash between teeth. Ring gear runout is determined by either the magnetic stand and roller tip dial indicator check while rotating the ring gear's smooth edge, or by checking backlash at 90-degree increments of the ring gear and comparing results. The simple ring gear backlash test for runout works just as well. Compare the variations at the 90-degree points as you check the ring gear backlash. Here the carrier and ring gear assembly are rolled into the axle for what should be the last time. Adjusters backed off make sure the bearing caps line up with the pin marks on the housing. Based on pre-tests and the right shim stack on the pinion, the gear set should only require backlash and bearing preload adjustments on the carrier, followed by a loaded tooth contact pattern test. All bolt threads have been cleaned and wire brushed as needed. Here, Permatex 242 Blue Thread Locker provides insurance against bolt loosening. It also offsets natural loss of bolt torque over time. The bearing adjuster rings can rotate if the bearing cap bolts are slightly loose. Use a box end wrench to bring the cap bolts up hand tight, then back them off 1/4 to 1/2 turn, leaving just enough clearance for carrier bearing cups to move laterally as the adjusters turn. Rotate the left or crown side adjuster toward the carrier. Tighten just enough to remove gear backlash. Now you can tighten the right side adjuster. At 0 backlash with the left adjustment, remove the play from the right side bearing. Before tightening the bearing preload at the right side adjuster, set up your dial indicator as shown here. The angle should allow the dial indicator plunger to move freely while meeting the ring gear tooth close to its rotational center line. Allow plenty of plunger range on the dial indicator. Finger snug the bearing cap bolts, allowing just enough slack for adjuster movement. A quick setting for preload is 6 adjuster notches for new bearings. After carefully adjusting preload, check the gear backlash. Some like 8 to 10 thousandths of an inch on an 11.5-inch axle. The Dodge Ram shop manual calls for optimal 5 to 7 thousandths backlash with an acceptable range of 3 to 10 thousandths. 6 thousandths of an inch is our goal with a 6-notch preload on the carrier bearings. Note that with backlash correct and preload at 6 adjuster notches, you should check the pinion rotational load as shown here. 42 inch-pounds works very nicely here. A combination of the 22 inch-pounds with pinion bearings alone and the added carrier bearing preload without the axle shafts in place. If backlash is off with the preload correct, you can move adjusters as needed and evenly. One notch loose at one side means one notch tighter at the other side. Work this until backlash is right and verify overall preload, 42 inch-pounds in this case. Factory range with new bearings is 30 to 50 inch-pounds for overall bearing preload, and that's a combination of the pinion preload plus the carrier preload. Note that 22 inch-pounds at the pinion plus 20 inch-pounds additional preload from the carrier achieves the 42 inch-pounds total. This is a good profile. Again, this is smooth rotational torque and not startup torque. Place some counter-force load on the pinion flange and get a tooth contact impression. If OK is shown here on both the drive and coast sides of the teeth, install the axle shafts before the final loaded test. Using Permatex 242 on threads, torque the bearing cap bolts, tighten the cap bolts in steps and cross pattern. These bolts are 16 mm stud size, grade 10.9 metric. Chrysler's Dodge Ram shop manuals call for 207 foot-pounds of torque on these bolts. While it is critical that the bearing cap bolts secure the bearing caps properly, you don't want to pull the threads out of the axle housing either. Consider the specifications for your year, make, and model truck axle. Consult a factory workshop manual and use discretion here. Let the bolts stand for a few minutes, then re-torque. Verify the pinion rotating torque. It should be correct at this stage. Adjust if necessary. Index the springs at the adjuster notches and set the lock spring bolts at 18 foot-pounds. Run a gear contact pattern all the way around before installing the axle shafts. Note the correct depth into the teeth and the length of the contact area. Backlash is now 5.5 thousandths or 55 10,000ths of an inch, halfway between 5 thousandths and 6 thousandths. Optimal for break-in to a final spec of 6 thousandths of an inch backlash. There is no ring gear runout issue, a tribute to the quality of the gear set. Again, remember that there are two types of gear cuts. On our 11.5 inch AAM axle pattern, we have a two-cut style. For details on the modern ring and pinion tooth cutting styles, see the American Axle and Manufacturing explanation and diagrams at their website. Install the axle shafts before making a final tooth contact test. The best axle flange gaskets are Felpro's impregnated type that do not require RTV sealant. This impregnated number 55328 gasket for the Dodge Ram came from Napa. Avoid using RTV sealant, which has created issues like breakdown of silicon and migration of RTV into bearings and gears. Use Permatex Loctite 242 Blue on clean axle flange bolts. Make sure axle shafts are clean. When installing axle shafts, hold the flange in a way that keeps the axle shaft on center. This will prevent banging of parts and potential damage to the differential case, bearings, or splines. Oil shaft inner splines and slide the shafts without force. Allow them to find their way into the side gear splines. Axle shaft bolt torque for the Dodge Ram is 95 to 100 foot-pounds. Bring torque up gradually and in cross with the parking brake set. Axle shaft flange bolts should be tight so that the parking brake can be set to drag lightly. Create around 10 foot-pounds of pinion flange resistance for this tooth contact pattern test. Rotate the pinion flange in both directions. This is the correct final tooth contact pattern. Here, under a light load of 10 foot-pounds drag from the emergency brake, no more, the tooth pattern looks good all the way around. Note the smoothing and clear impression created as the brake drag simulates a load. Coast, drive, relationship of heel and toe, root and crown of teeth. This is a desirable result. Close-up of the drive pattern shows ample tooth contact length, the right engagement depth of the pinion, with correct margins above and below the contact areas. This is proof that the 6 thousandths of an inch backlash will work well in this case. Correct coast pattern will run quieter and provides long service. On deceleration with a trailer in tow, down an 8% grade, it's reassuring to know that the ring and pinion teeth engage like this. Wipe off the ring gear teeth, Denatured alcohol works well if needed. Vacuum out the axle cavity and around the differential to remove any debris from the adjusters or marking compound residue. All hardware is torqued to specification, tooth contact is right, and bearings have correct preload. This axle is ready for the cover and an oil fill. Before installing this differential cover, it's time for cleaning and paint. This OEM cover has minor rust formation, enough to require glass beading. Bolts can be wire brushed. This kind of rust beneath the OEM paint does require glass beading. This is strictly surface though, as the Ram 3500 has resided in a high desert climate since new. Axles receive little paint in the manufacturing process. We'll fix this. The differential cover looks like new after glass beading, wash, and dry. A coat of primer and a fresh coat of semi-gloss black paint will restore the cover. The inside will not be painted. Chrysler's differential cover gasket is exceptional. This Mopar part can be reused if in good, leak-proof condition. Use Loctite Permatex 242 blue on cover bolt threads. Install the bolts using the cross pattern. Painted with black semi-gloss engine enamel, tighten the cover bolts in steps to a torque setting of 30 foot-pounds. Do not over-torque or you will distort the cover. Fill plug torque is 24 foot-pounds. New OEM bolts at the pinion flange are recommended in the factory shop manual. Align your disassembly indexing marks. Tighten the bolts and cross. On the Dodge Ram, the spec is 85 foot-pounds. Use Loctite 242 on clean bolt threads. The oil type is a controversy. The choice here is Mopar Synthetic 75W 140 weight gear lube. Some believe break-in lube should be a 75W90 or even a straight 90 weight. The main objective during break-in is to protect the axle from overheating. 75W140 offers the widest range of temperature and load protection. 4 quarts of Mopar oil is 128 fluid ounces. Fill for the 11.5-inch Dodge Ram axle is 122 fluid ounces. 4 quarts is close enough on a complete axle drain with the axle shaft removal and cleaned parts. After putting fluid into the axle, before installing the wheels and tires, we idled the truck unloaded in low gear for 10 minutes on jack stands to circulate oil and allow the bearings to fully saturate with oil. We then installed wheels and tires before taking a light test drive on the road. With proper break-in, this rugged axle will be trouble-free for several 100,000 miles. A few footnotes about break-in. Axles require break-in after rebuilding, just like an engine. Axle concerns during break-in are heat and load, as gear teeth establish a lifetime contact pattern. Most builders recommend initial short trips under light load, allowing the axle to cool down completely between runs of 10 to 30 miles. This goes on for a couple 100 miles, without trailering or extreme acceleration loads. At 500 miles, towing can begin, with complete cool-down periods and short runs during the first tows. Change the oil warm at 500 miles. This will remove any gear coating that could be floating around in the axle. Use appropriate oil at the refill. Consider your climate, driving conditions, and the axle temperature exposure.
This is a Dodge Ram 3500 ring-and-pinion gear changeout.
In the AAM 9 1/4 inch axle,
The job begins with the removal of the rotors, the calipers, and the front axle shafts and wheel hub bearing assemblies. When removing the calipers, be certain to hang the calipers by Mechanix wire to prevent damage to the brake hoses. Loosening the left tie rod end can be simplified with the use of an air hammer and blunt-pointed chisel. A few sharp raps in the pocket end of the ball stud, and the joint will
separate.
Use of the air hammer can actually prevent damage to parts while quickly disassembling a tie rod end or ball joint. With the tie rod out of the way, the differential cover can be loosened to drain the oil. Once the oil is drained, remove the cover completely.
Caution: 2013 up Ram trucks have a front axle shaft disconnect system. The right side axle shaft is two pieces with a disconnect collar. An electronically actuated shift fork connects and disconnects the two shaft sections. Be aware that the differential case cannot be removed until the right side inner axle shaft slides outward enough to clear the differential case and bearing flange. The axle shaft seal must be removed to allow the inner axle shaft to slide out far enough. The right side axle shaft seal must be removed to perform differential ring and pinion gear service. A new axle shaft seal must be installed during the parts reassembly. For 2013 up Ram trucks, follow the factory service manual steps to remove the axle shaft pieces and seal. Here are the basic steps. Remove the axle disconnect housing. The shift fork is part of the assembly. Next, remove the outer axle shaft and wheel hub as shown in the video how-to steps. The inner axle shaft and shift collar are now visible at the axle shaft disconnect opening in the axle housing. The axle shaft seal is to the right of the disconnect opening in the axle housing. Using a long, suitable driver, the seal can be driven from the outer end of the axle housing into the disconnect opening in the axle housing. Do not damage the seal housing or seal bore. Once the seal has been removed, the inner axle shaft can slide outward to clear the differential. The differential assembly can then be removed. Here's an inexpensive tool solution for installing the axle shaft seal. There are factory recommended tools for installing the axle shaft seals. See the Ram factory service manual. One alternative for a long reach like the right side axle seal is the use of threaded rod stock, grade 5 US or harder. A large socket or a sleeve or even a pipe will work here, and some plate steel. The long rod stock can be run from the outer end of the axle housing into the disconnect opening. A piece of flat plate at the outer opening of the axle housing is held in place with a washer and nut. The rod runs through the new seal's bore and through the large socket sleeve or pipe. This socket or sleeve fits against the face of the new seal. Avoid damaging the lip of the seal. Use the long rod and nuts to pull the new seal into position. The rod stock runs through the socket or sleeve. Washers or plate and a nut fit at the inner end of the rod stock. Tighten the nuts to squarely pull the socket, sleeve, or pipe and the seal carefully into position. Caution: the inner axle shaft piece must be in place before installing the right side axle seal. For demonstrating front wheel hub and axle shaft removal, our prototype truck is a 2005 Ram 3500 single rear wheel pickup. Similar steps apply to the 2012 and earlier Ram 2500 3500 AAM 9 1/4 axle shafts and unit bearing wheel hubs. These steps also apply to the 2013 up Ram left front axle shaft and the outer section of the 2013 up right side axle shaft. On a 2013 up Ram equipped with the axle shaft disconnect system, be certain to remove the front axle disconnect assembly from the axle housing before removing the right side outer axle shaft.
Clean up all bores and vacuum the parts to make sure the axle shafts reinstall in a clean axle. A quality shop vacuum will remove this debris. Set the axle assemblies aside in a safe place and keep the axle shafts aligned with the hubs to prevent damage to the U-joint. Here, the bores have been cleaned thoroughly, and this axle is actually ready for parts reinstallation. Parts go into the parts washing cabinet. At 140 to 150 degrees Fahrenheit, the parts washing cabinet is ideal for the differential as well. Mark the position of the bearing caps and their precise locations during disassembly. Bearing preload is set with adjuster rings. These adjuster rings can be loosened with a OTC Miller 8883A spanner tool. Prevent the weighty differential assembly from rolling out of the axle housing once you've loosened the adjusters. The only parts requiring attention here are the ring gear and bearings. Ring gear bolts are left-hand thread. Tap at opposite sides evenly. Wipe out the differential housing with a lint-free rag. The new ring gear and pinion get washed as well along with hardware. And the differential assembly. Heating the ring gear uniformly to 140 degrees Fahrenheit enables sliding the ring gear onto the carrier flange more readily. Use new ring gear bolts with 271 red Loctite on the threads. These are left-hand thread. Pull them up evenly and in cross. Pull the ring gear on uniformly to make sure you don't bind it. Check the final torque at 103 foot-pounds. Remove the original pinion bearing to access the shim for measurement. Size the bearing bores of the original bearings to use as a trial fit for the new pinion shaft. Make sure these bores are concentric and round to provide a finger press fit onto the pinion shaft. Here the shims are stacked to match the original shim thickness. Experience has me adding a few thousandths of an inch of extra shim thickness for the trial fit. Note that these bearings slide on with finger pressure, yet stay on center. I grind the lock portion of the original nut off to enable use of the pinion nut for trial fitment. These are all the parts necessary for the trial fitment of the ring and pinion gear. Note that the crush sleeve is not a part of this assembly at this point, and these are the original bearings resized to serve as trial fitment tools. Original bearings in good condition provide accurate trial fitment. The pinion flange seal is not installed at this point. Set the adjuster nut for a slight drag on the bearings, which will enable better tooth contact patterns when you get to that point. Install the clean adjuster rings in their respective pre-marked areas. Change the bearings as described in the 11.5 AAM axle
Coverage.
Begin the trial fitment by installing the bearing caps tightened uniformly and in cross. Bring them to 30 to 40 foot-pounds to seat the caps on each side, and then back off these bolts 1/4 of a turn to allow rotation of the adjuster rings. Use the Miller spanner tool to tighten the adjusters for preloading the bearings, taking the play out of each end. If play is removed with zero backlash of the ring and pinion gear, tightening the preload on the right side will push the ring gear over just enough to establish the proper backlash. Now you can paint the teeth with marking compound before getting your first ring and pinion tooth contact pattern. Keep tension on the pinion gear and rotate the ring gear with a wrench. This will give you a deep contact pattern and an accurate reading of both the backlash and the depth of the pinion gear. Run the tooth contact patterns 90 degrees apart to confirm backlash and runout at the same time. Once the tooth contact pattern has been established, you can install the new bearing on the pinion with the correct shim thickness. You'll install a new pinion nut, new crush sleeve, and a new seal. Carefully press the bearing into place with the shims, as illustrated at the 11.5 axle
Coverage.
Make sure the new bearing is in place before installing the seal. I coat the splines and forward face with Superflex. I coat the edge of the seal and install it with a Miller tool. If you don't have this seal driver, you can improvise with a large socket. The rotational pinion bearing preload is set with an inch-pound torque wrench. This is the rotating force, not the startup torque. Calling for 15 to 25 inch-pounds with new bearings, I set the preload to 22 inch-pound with the pinion seal in place. The differential carrier is now installed with the bearing caps and the adjuster rings free to rotate. I set the bearing preload and the backlash on the ring gear simultaneously before putting the lock springs in place. Carrier bearing preload adds to the pinion bearing preload, and the total between the pinion preload and the carrier bearing preload should be 30 to 50 inch-pounds of rotational force at the pinion. Again, take marking compound imprints with a slight drag to get the tooth contact pattern and check the backlash as well. Using the same shims and preload settings as the trial fit, I'm getting a very desirable tooth contact pattern. I like to check the backlash at 4 points on the ring gear. This assures me that the ring gear is running true. Tested with the dial indicator. Final bearing preload for the combination pinion and carrier bearings is 42 to 45 inch-pounds rotational force. Final torque on the cap bolts should be 63 foot-pounds with clean threads and Loctite 242 blue on the threads. Align the drive shaft with the original flange marks to be sure that it's back in the same balance position. Axle shafts and hub bearings can be installed now as an assembly. Put clean grease on the end of the splines. This is a weighty assembly. Keep parts aligned as you insert the axle shaft carefully through the clean tube and through the seal into the splines on the side gear of the differential. Align the splines carefully and align the hub carefully with the steering knuckle flange. Use Loctite 242 blue medium strength on the steering knuckle to hub flange bolts. Insert the bolts from the back side of the steering knuckle and tighten them in cross, bringing them to a final torque of 149 foot-pounds. The shorter left side axle shaft is actually easier to install and to hold the shaft on center line. Note the use of grease at the splines and seal riding area. Install the ABS sensor using care to keep these parts clean. Route the ABS wires in their original positions. Chrysler uses the best designed differential cover gasket. It can be reused if clean and free of any kind of damage. Use Loctite 242 on the bolts and torque them to 30 foot-pounds. Our lubricant of choice is Mopar 75W140 weight synthetic. Torque the fill plug to 24 foot-pounds. Reinstall the tie rod end. Torque this nut to 40 foot-pounds and an additional 90-degree turn of the nut. Install the rotors and the calipers, making sure the brake hoses are in alignment. Check all parts to be certain that they turn freely and operate safely and properly. This wraps up the 9 1/4 AAM axle rebuild.
AAM's 9 1/4, 10 1/2, and 11 1/2 inch axle designs have several quick service features. The crush sleeve for pinion preload adjustment and the threaded adjusting rings for setting carrier bearing preload are two time savers. The preload adjuster rings have external slots for rotating the ring. To rotate these adjusters, Miller SPX has produced a special spanner for the task. The Miller SPX 8883A tool is the official tool for the adjuster nuts on AAM 9 1/4 inch, 10 1/2 inch, and 11 1/2 inch Chrysler, Dodge, and Ram axles, and the GMC truck axles. The Miller SPX 8883A tool is available at the SPX website. If your shop does this work regularly or you prefer using the factory recommended tools for your axle work, consider investing in this tool. For those doing this job one time or not being able to afford the 8883A tool, you can fabricate a similar tool with basic welding equipment and a grinder. We do use the Miller SPX 8883A tool, but in the interest of viewers who need to make their own spanner, we built a functional tool for this project. The materials include flat steel strap 1/4 inch thick, as shown at the left, an old and expendable impact socket, and a high tensile used steering knuckle bolt. Pieces are cut to rough size. The plate is the body of the tool. 1/2 inch square insert will accept a ratchet. The bolt shank can be made into the small hook arm. The use of a power grinder and file create a notch in the high tensile steel bolt shank. The grinder makes quicker work of this task. Here, a torch quickly cuts a hole for the modified socket section. Note the rough shaping of the arc and leveraging the pull, similar to the goal with the factory tool. The arc is not contoured for the adjuster ring surface. It leads to a leverage pivot point. This tool actually fits the 9 1/4 inch, 10 1/2 inch, and 11 1/2 inch AAM axle adjuster rings, regardless of the ring diameter. The bevel at the plate edge will allow welds to burn into each other for maximum strength. The plate is now welded to the shank. Weld from the opposite side overlaps and creates one solid piece of metal at the weld section. Filler material is 70,000 psi tensile. Grinding has flattened the hook to fit the slots. Further shaping and the socket gets welded to the plate. The socket has been cut to provide ratchet hookup from either side. A simple 1/2 inch square drive receiver. Welding and surface grinding have eliminated any trace of the original bolt and plate as separate pieces. Metal fusion was complete. Here, the ratchet fits readily into the tool receiver. This tool is ready for a trial fit. The new tool fits the adjuster ring, its hook grabbing the slot hole much like the factory tool. The force and hook angle wants to rotate the ring. The hook angle is critical to get this effect. The hook ledge catches the inside edge of the ring as shown and turns the ring. The tool was tested on the 11 1/2 inch ring and pinion gear set installation. There is one caution. For this difficult application, torque is limited for both the homemade tool and the factory tool. Avoid bending or shearing off the hook arm on either design. This tool is made for one-time use and not intended to replace or outperform the Miller SPX 8883A spanner. The hook is a weak point due to the narrow width required with this tool application. To fit the slot, the hook must be small and narrow. Miller SPX notes do not use for removal, indicating the factory 8883A tool will not handle excessive force in the case of a binding or stubborn adjuster ring. Even bearing preload, after years of hard axle service, can create resistance beyond the range of the Miller SPX 8883A or this homemade tool.